Hello all, I'm Dr. Rizvi and this is our part 4 of the video on response surface methodology. In the previous videos, we have already discussed how to develop a RSM model for 20 experiment using central composite design. We have also discussed how to feed the data in the response table and how to analyze it and how to determine the type of model for the particular data that we have fed and obtained through experiments. Later in the video, we have also discussed about the analysis of variance and the actual equation that we have obtained for the particular response. In this video, we will discuss that how we will model the graph using response surface plots. So to model the graphs, we will click on model graphs. And now after clicking on the model graph, we will click on the 3D surfaces. Upon clicking on the 3D surfaces, we will obtain these type of response surface plots. The present plot is between the feed and the speed as parameter against the surface roughness that we have obtained for the 20 experiments. Here we can change our terms. It is showing between A and B, that is speed and feed. We can also obtain the graph between speed and depth of cut and that between feed and depth of cut. Starting with speed and feed. Here you can see that it shows a linear relationship between the speed and the surface roughness as well as speed and feed, because this is a two function interaction method model. And for two in function interaction model or linear model, we will generally obtain a linear graph. If we obtain a curve graph, then it must be having some quadratic or cubic terms in it. The model must be having some quadratic or cubic terms in it. For this, we are already having two FI model. So this is a linear graph that we have obtained here for speed, feed, and with surface roughness. We can also rotate the graphs like this to different angle as and when required. For A and C, that is the speed and depth of cut, you can see that the graph is obtained like this. From the side view, we can see the graph like this, that it is decreasing. This as we are decreasing the speed, the surface roughness is also decreasing. It is following a decreasing trend, or we can say that when the speed is increasing, the surface roughness is also increasing with it. Similar is the case with the depth of cut. When we are in decreasing the surface roughness, or we can say it in a reverse way, that when we are increasing the depth of cut, the surface roughness is decreasing. So this is how you can interpret the graphs as per your data. Similarly, the third graph shown here is between depth of cut and feed against surface roughness. This is almost a flat curve that we are seeing here, flat line, and no major change is being observed between the parameters and surface roughness. The value is lying near about 3.2 and 3.6. So this is how you can interpret your data for the model graphs. After performing all these work, you can also perform the model validation. And to perform the model validation, you have to use the point prediction method that is provided in Design Expert. You just have to click on point prediction and you will get these two tables. Here you can see the levels for the point prediction. These are the center level as we are using the central composite design. So the point prediction will be at the center points, that is 650 speed, 0.4 feed, and 10 depth of cut. For this, the values obtained here are the mean low value and mean high value. High value for mean and low value for mean, that is CI. 95% CI low for mean, that is it is coming 3.2338, and 95% CI high for mean is 3.3872, and their average, it is showing the predicted mean 3.3105. So this is the predicted value for the surface roughness on the center point. Now to validate your experiment, you have to conduct a validation run. So you will conduct another experiment on these center values, and you will get a value of surface roughness on the validation run experiment. So you can place it here. You can develop a table like this for model validation. You have developed you have predicted the value by the point prediction method as 3.3105, and after model validation, the validation run, you will get some value. For example, in our experiment we have got the surface roughness value as 3.21. So on comparing the validation run value and the prediction value, we will get some error. By using the formula, we will get the error. If the error is less than 5%, then our value is valid and accurate, and the model that we have developed is valid and accurate. So that's all for today. We have discussed in this lecture about the model surface plots and the model validation run. Thank you.